I would like to present my work on a topic wide function method in pressurized thermoshock analysis for those Clad defect in a reactor pressurized vessel. My content of my presentation is a following motivation. The type of reactor we were used in Ukraine, pressurized thermoshock analysis, calculation stress intensity factor using analytical solution, verification result, and conclusion. Assessment of brittle strength is important for nuclear equipment. Actually, brittle determination is allowable time operation for reactor pressure vessel. Evaluation of brittle margin we can split into two cases. The second one is about evaluation resistance curve, and the first one. And the second one is evaluation strength intensity factor. The present study focused on the second one aspect. Nowadays, finite element analysis plays a key role in mechanical especially when we're talking about a lot of accident scenario, and using for this finite element method. The formulas for calculation stress intensity factor in time. The difficulty is according the cladding. One of modern methods for pressurized thermoshock analysis is polynomial solution. It's well-known known method and used in different standards such as Vitalii. But shape coefficient for Vitalii obtained for a plate. Therefore, goal of the current study is estimation the applicability of the Vitalii and Ukrainian industry industry document for 177 formulas for fracture analysis of Weber 1000 RPV. Following the Chapuliot methodology and attempt if made to propose more precise formulas for Weber 1000 cylinder. In Ukraine, used two types of nuclear units. The first one is Weber 1000, and the second unit is Weber 440. The main dangerous point of that impact on long-term operation are well joined. Well joined number 3 and number 4. This applies to both types of reactor. Using this standard, we can select it size of defect and evaluation stress intensity factor. For the determination shape factor, we built a finite element model taking into account the symmetry conditions. Finite element model was constructed 1/4 part of the crack. There are 10 element contours around a crib, and the crack tip was split into 54 segments. The radius of the first contour is 0.1 millimeters, and the last contour radius is 1 millimeter. To perform the calculation, we use following boundary condition. We use frictionless support for all ends and apply loads only for crack surface. Okay. Also, when crack located in a high temperature zone, we must also take into account residual stress. For obtain shape factor, we use following equation from finite element model. We obtained J integral, and for each degrees of polynomial, obtain shape factor. In the table present shape factor, calculated shape factor, and using shape factor and polynomial stress, we can evaluation stress intensity factor. The composition of stress field into polynomials is important items. Main difficulty at this stage is to represent the stress discontinuity at interface between the cladding and the base metal. Therefore, the stress field is divided along x coordinate in two fields. The fields in base metal and fields in the cladding. Using extrapolation and polynomial expansion function, we obtain smooth curve stress for full thickness, and use superposition principle, we obtain stress jump in a cladding. Our shape factors was verification. For verification, we selected to simulate real thermal shock loads, pressure on the inner surface, linear temperature distribution, residual stress, and combined all load. In the table, you can see that counted my own counted coefficient and Vitalii coefficient good agreement with ANSYS result. Also, according to Ukrainian rules, for calculation strength intensity factor, we have to use industry standard document FO 177. The document provides for the calculation of the stress intensity factor only for surface cracks and different in elastic model in base metal and cladding is not taken into account. Also, document considered only three types of load: membrane and bending stress in base metal and membrane stress in a cladding. For membrane stress, stress intensity factor for membrane stress agreement with other methodic, but for testing task, bending stress and membrane stress, but not agreement. Also, representing actual stress as first order polynomial make impossible to describe actual stress and residual stress. In the picture, you can see blue line is actual stress in the wall, and red line is approximation function stress by soil. Also, the calculation full emergency scenario. For this calculation, we use submodeling technology and build two models. One model is full reactor pressure vessel and 1 minute. And second model, which submodel with crack tip. Here you can see that Vitalii and my counted coefficient good agreement, and so is also agreement, but SIF intensity factor is so less. The main conclusion is that Vitalii coefficient determination for the plate and my counted coefficient for the cylinder can be used to assess the pressure thermal shock for VVR 1000 in a vessel. Okay. I would like to thank for the support ISIS and Yen and 2+. Thank you for your attention.